everyone, and welcome to the IIoT World Energy Day for our session today around modern asset management for the energy industry. We're excited to have you guys all here, and I've heard some great conversations and dialogue earlier in the day with the sessions that have taken place. So hope that you all get the same out of this session as well. I'm Ann Emberson, AVP of Digital for Ecolab. And I am welcomed with Dominic from Hive MQ. Dominic, I'll turn it over to you to introduce yourself.
Yeah, thank you, Anne. So hi, everybody. My name is Dominic Obermeier. I'm CTO at a company called Hive MQ. So we are a global company based in Germany and also in the US that is helping companies connecting their assets and move data where they need to be in a fast and efficient way. I am working now more than 10 years on technologies like MQTT, which are used across all industries right now to connect things like cars, but also things like wellheads and so on to get real-time insights and move the data where it needs to be. And I was fortunate enough to also help with the MQTT specifications. And I'm currently working on other industry specifications, like, for example, MQTT Sparkplug, that is used to help move data and then also make sense of the data, and also to create more efficiencies, and also basically help companies modernize themselves and do something with the data which they actually need to do. And with that, I'm excited to have the session.
Awesome. Thank you so much, Dominic. And as we're going through the session, if the audience will please add questions in the Q&A below, we definitely want to make this as interactive as possible. So as we're all learning and working together, add your questions in and we'll do our best to answer each one of those as we go through the session. And if we don't have time for all of them, we'll follow up with Q&A following the session. So just to start a little bit, Dominic, you mentioned kind of what Hive MQ provides, but what do you see companies' greatest assets on how they integrate their IT and OT? I know there's a lot of conversation around IT OT integration and the disparity between the two, although they've both been around for some time. What do you see as the greatest advantages companies can gain from there?
Yeah, it's a very good question, and especially when it comes to bridging the IT OT gap, this is, I think, a key topic a lot of people and a lot of companies are struggling with to really get the most out of that for connecting their assets. And I mean, this is true for many industries. We have this in the energy industry, but we also have this in the manufacturing industry and so on. I mean, the gap between OT and IT is real. And so just to start with an example, I had a very interesting conversation with an executive of a company a while ago who have like a real problem that on the remote sites, they have a problem when detecting spillages with their wellheads, and it can take them up to 20 minutes to detect any kind of problem there, which is like an extremely long time. And I probably don't need to talk about why this is a huge problem to have detected. And what these companies are looking for are ways to basically make a kind of almost real-time data transmission possible. In real time, in the sense of as fast as possible, of course, which means what you're looking for is as soon as something is detected, like a spillage, this is really the time it should take to detect that problem and then do something against that. And with existing technologies, this is something that is pretty hard to do. And in a lot of recent conversations, and I show later something where we have collected data with IIoT World, where we did a survey and really asked decision makers worldwide, what are the technologies right now, what are in use, and what has the most mind share? And there are some very exciting things I want to talk about later on in this session. They'll share some of that. But just a quick thing, for example, technologies like Modbus, they are in practice like very hard to use in practice in an efficient way and in a way that is basically also cheap enough to do that in a remote setting. And again, this is something I'm excited to talk about later on, what one can do and like the concrete technologies that are being used today and what one can do here. But overall, what we see with customers worldwide is as soon as you get the possibility to have real time, like instant access to data and move them where they need to be it in the cloud or on a remote site or wherever, this is something that is really great. And Gartner, industry analyst, they a while back, they also made a survey, and they claim that nowadays 20% of the data is produced outside of data centers, and 80% is produced in data centers. In the next few years, this will switch radically. This means more than 80% of all data will be produced outside of the data center and needs to be moved back somewhere else. And this is where core technology is needed. And businesses today need to prepare themselves to build a foundation so they can build upon the use cases for later on. And when it comes to modernizing the infrastructure, it's not about the use cases that are there today, but also what are the use cases in the next 5 years. That is being done because, I mean, the competition is not sleeping there, not at all. And the technologies are out there to really modernize, and also in a very effective way.
That's great, Dominic. And as companies are moving to making faster, smarter decisions to advance the energy industry, you mentioned about modernizing asset management. What do you see as kind of the key components of getting this more real-time information to provide these quicker and smarter decisions to companies?
So, I mean, there are many ways. So I think when it comes to down to technologies, there is really something, some technologies people really need to be aware of. And one of them is MQTT. And MQTT is something for people who are not aware of that. This is a technology that is, while a lot of people are talking about it right now, it's a technology which has been developed for quite some time and is actually pretty old. And MQTT is a bit of a history before going into more details here. It was developed in 1999 for remote monitoring of oil pipelines. And it was developed by a company called Arcam and also IBM. And what they did is, this was for Phillips 66, they helped Phillips 66 to use their newly developed TCP stack that was using satellite communication. And one of the key challenges is for monitoring of oil pipelines is that you are in very remote areas, obviously. And what this also means is back then you only had satellite communication for moving the data, and this was extremely expensive. And so they developed a technology called MQTT that helped them to move the data fast and efficiently, even back then in 1999. And since then, basically for 10 years, there was not a lot of buzz around MQTT, but now for 10 years, people are rediscovering their technology in all industries, from manufacturing to energy industry, to even connected cars, for connecting all of the things, all of the assets, and then get this kind of real-time insights into all aspects of the business, from sensors to actors to all applications. And this even over things like satellite communication, or things like narrowband IoT or LTE-M, or traditional mobile networks, but also over wired networks. So this is a technology that can be used from even inside factories, but also for monitoring remote sites. And this is what makes it also so useful. And this is also, frankly, why MQTT really got a comeback, actually, and is now the dominant technology for connecting things also over the internet. And I think this might be a good start now to also show some of the results of a survey we did with IIoT World last year in October. And I'll quickly show my screen here so people will be able to see my screen. And this is a report that is much more elaborate, but I'll just show you 2 slides here. And one of the questions that was asked in the survey was, which of the following protocols do you use today to connect your equipment? And I mean, this is something that people won't be surprised that Modbus with 45.9% was still predominant. And then also, I mean, this is of course more on the factories, technologies like OPC UA, they're there, but also Profibus or Profinet. And also, not surprisingly, also HTTP that is also used today to help bridge the IT and OT gap was used a lot as technologies. And what is also interesting is that MQTT as a technology was used today by 50% of the participants. And there is also something I want to talk later on, is also a communication standard called MQTT Sparkplug. And as for people who are not aware of that, I will talk later about this more, but this is something also companies like Chevron use to connect all of their assets. This is something that is not widely used today. And frankly, I'm a bit surprised to see that because this is something that much more companies should be aware of. Now, the second question though was, which of the following protocols do you consider strategic to fulfill your IIoT strategy? And also here you see MQTT is by 50% of the people was considered strategic. And what is interesting that MQTT Sparkplug, almost 30% of all the people responding here, they are considering this strategic. And by the way, the participants used here they're from architects to senior management. There was really a large group here being surveyed. So this is not only technologists, but mostly business people were answering here. And if you just look at MQTT Sparkplug here, 5% are using it today, but 30% consider it strategic. This means we see this huge gap here and this large amount of companies who are actively investing in these technologies to fulfill the business needs. And if you look at protocols like OPC UA, again, this is more on the for factories relevant here, but also we see here that this is really something that is not in there. And protocols like Modbus, you don't see here at all. They're here in other, because this kind of legacy communication standards, I mean, while widely deployed today, are not considered strategic. I mean, they are there. But the question is like, what's next and how can we modernize without even replacing everything we have here? But this is something I found extremely interesting to see how companies worldwide think about it and what kind of communication standards they consider relevant also going forward into the future.
That's great, Dominic. We have a couple of questions, I think, as a follow-up to what you presented there. So around MQTT, how is that better than Ethernet IP from your perspective? What do you see as the benefits?
Yeah, and this is a very good question. And I mean, the thing about MQTT is MQTT as a communication standard. It uses Ethernet and IP actually. So it's similar. There is this concept of the OC stack where we have these kind of layers where usually, for example, you could have Ethernet and then you have IP on top. And then, for example, you could have TCP on top, and then there are application protocols like HTTP and others on top. This is something you, for example, in the web, you see this very often, where you have TCP and then probably also TLS, SSL for security, and then there's HTTP and other protocols. And MQTT is one of the technologies that is using this kind of layered approach by saying, okay, it uses the communication standards already in place, already built into their equipments, like TCP/IP, and then it's an application protocol like HTTP. So this means MQTT is using Ethernet and IP and leveraging that. And it provides much richer, let's say, semantics, because MQTT uses a model called publish-subscribe, which completely decouples the communication. And I will just quickly show this also to people here, because this might be extremely relevant. So MQTT uses, and I'll just show my screen here. And this is by the way from a blog post series, which is called MQTT Essentials, that shows in 10 basically very small blog posts all core concepts. So for people who are interested afterwards, this is really something. There's also an ebook available where you can also dig deeper if this is interesting. What we see here is that MQTT as a technology actually uses the IP stack, TCP on top, and then there's also MQTT. And this is something that is highly relevant, because this allows you to already use your existing equipment that has a TCP IP stack, which many of these have, and then just use MQTT on top of it.
So speaking of using existing equipment, do you provide a platform or IoT portal to manage assets or connect with ERP such as SAP or Oracle? Yes. So this is something like my company HivenQ, what we do for a living. So what we provide is an enterprise MQTT platform that allows you to connect all your assets, and also in a multi-tiered fashion. This means, for example, we have customers who have factories, for example. They have their on-premises deployments, they have their clouds, and actually they're building the central nervous system for the company. And we're providing the building blocks and actually the technology for connecting factories, for connecting assets, for connecting also things like cars for companies, and then bring it together into one platform where then you can decide where to move the data. And very often you see databases being used where data is being put in there. So SAP directly, this is usually not something you would put in directly from the platform, but there are approaches here. So for people who are interested in that, please feel free to reach out. But usually there is like this kind of data integrations also happening, so that in the end you get this into your SAP. And and very often you also have own microservices that are being developed by the companies themselves, and they're also integrated into the platform. And HivenQ as a communication platform. We'll quickly show that also. This is really something you get all your devices basically in, and the HivenQ platform, that can be run anywhere. It can be run on all clouds. It can be run on cloud native environments like Kubernetes and OpenShift, which we see with a lot of customers nowadays. But also that we have managed services for customers who do not want to run their own infrastructures. And then there are many extensions where we actually integrate with all of the technologies that are being used by enterprises. And so we have, for example, we have one of the largest OEM in the US as one of our customers. And they use it extensively also for connecting all of their things, all of their own services, and bring back information bidirectionally, so they can move data from the field into the cloud and into their basically enterprise systems, but also move back data into the field and provide, for example, commands, push back machine learning models, they, for example, they calculate it in the cloud and so on, and really provide that kind of data movement
from all aspects, from edge to cloud, basically.
And there's a follow-on question in regards to edge, because with a lot of energy companies having equipment in remote parts of the world, edge devices and edge connectivity can be really important in the industry. How do you see MQTT form part of the edge when we talk about edge enterprises and what that looks like?
Yeah, I think a key is when we talk about edge, especially when it comes to remote assets, is sometimes the connectivity is not as good as it should be, especially when we have very remote areas. And what this means is, usually we are recommending a kind of tiered approach. This means for any kind of data, we should not assume that cloud connectivity is essentially always there, because it's not always there. Sometimes it's slow, and there are, in practice, sometimes there is a problem with the underlying infrastructure. This means, this is also, by the way, true for a factory. So I would not recommend that the manufacturing process is reliant on the cloud connectivity, because this is a huge problem, and any kind of downtime is extremely expensive. And so one needs to build very resilient systems, which means we always recommend to have an MQTT infrastructure locally on every site. This allows that all of the assets can freely communicate locally, and then also have a cloud infrastructure, which could be their own data center for some companies, but it could also be a public cloud for other companies. Frankly, most of the Fortune 500 companies we work with, they favor their own data centers, but we also see many companies also moving towards leveraging cloud infrastructure more. But essentially, how we can help here is we don't really care so much, because the platform runs in their own data centers, but in the cloud. But yeah, we clearly see a trend towards the cloud, but still most Fortune 500 companies are a bit more conservative when it comes to data centers. And so, and you connect all of these sites then to the data center, and then you get this kind of large data broker basically in the cloud, and then you have the smaller ones on site. And every time there's the connectivity, which is hopefully most of the time, you have the kind of full central nervous system between all of the assets, but also you can, in case of any problems, still locally, you don't lose any data, and there's no problem if there's no cloud connectivity. So I would always recommend to architect for resiliency, and this is also something we help our customers with, that this is possible.
And obviously, cost is a critical component for decision making and realizing the value as we connect the IT and OT world together, leveraging the IoT devices. How do you see the different hybrid scenarios or in different ways of connectivity driving the cost so that companies can realize that total cost of their assets?
Yeah. So cost is a huge thing, and this is also why technologies like Modbus. So this was also one of the recent conversations I had, where a company was unhappy about the cost their Modbus infrastructure produced. This is because of the way how things are architected, and for MQTT infrastructures, the cost of sending data is usually extremely low. And there's a reason for that. I said in the beginning that MQTT as technology was invented for oil pipeline monitoring, and it was built for satellite communication. For people who have dealt with satellite communication in the past, they know that this is extremely expensive. It continues to be expensive. Not as expensive as it was, but it's still pretty expensive. And also availability is not always as it should be. But anyway, when it comes to cost, MQTT was architected for that. And one of the inventors of MQTT, Andy Stanford Clark, he told me once that back then, when they invented MQTT, every byte, which means like the smallest part of data that they could spare, would result in 5-digit savings of money. This means they were also tasked to have really the smallest amount of data and overhead for carrying data. And this also means MQTT uses something that is called a publish-subscribe architecture. And this is for, compared to most protocols used today in the OT space, is quite different, because MQTT is used in a report by exception case. This means data is only transmitted if there is a data change. So the classic poll response protocols, they are basically using whatever 1 second interval or even less, polling for new data, and as soon as new data is there, distributing the data. With MQTT, it uses a so-called brokered approach, where you have a broker, you have a data producer, and you have multiple data consumers. And I just show a picture so people can see that. So let me just bring up my screen. So here it is. So how MQTT is usually used, and in this picture, this uses a car, but as a data producer, but basically it can also be something else. You have a kind of broker in the middle that is responsible for distributing the data where it needs to be. And then you have a data producer, which could be, in this case, we show a speed meter, but when it comes to some asset, it could also be an asset that is producing data. And when it produces the data, it sends the data to the broker, and the broker distributes the data to every participant who is interested in this piece of data. And it uses a so-called push model. This means data is pushed into the broker, and the broker is pushing the data out to the devices. This could be one device or 1 million devices, like literally we have customers doing more than 1 million devices pushing out data. And this does it in the most efficient way, because it actually uses, if people are using a mobile phone, it uses similarly to your mobile phone. As soon as you receive a message, for example, iMessage or WhatsApp or whatever, it uses a down channel directly. And the same principle is used by MQTT. Data is being sent and then it's being pushed out. This also means if there's no data change, you won't push any new data. And this is really something that is critical, because data transmission is one of the most expensive things you can do when you connect your assets, especially over technologies like satellite communication and so on. And secondly, there is, besides cost, a second problem when you connect something remotely is latency. This means, I mean, I'm here in the office, I have 5G connectivity. With 5G connectivity, I can send a lot of data in very low latency. If I'm on a remote site, chances are that I have very low bandwidth, so I cannot send a lot of data, and it takes very long. I have a very long, high latency. And with this high latency, this also means things get unresponsive. So the smaller the data packets are that get sent, even the better the experience is and the faster the data is transmitted. And so by MQTT being ultra efficient, it serves two things: saving costs by, on the one side, being as small as possible, but also having a publish-subscribe architecture. And secondly, it really sends data extremely fast compared to most other technologies out in the market.
Excellent. We have a question from the audience. How do different protocols affect the asset management process? And is there a difference in the information type, speed, and capability?
Yeah, it's a good question. It's actually a pretty large question. So there is, so can you just repeat the question so I can focus on the right thing here? Yeah, yes. Here we have difference in information type, speed, capability. Yeah, thank you. So it really depends now on, this would be like, there are these comparisons between different technologies. So for example, a technology that is also used today, we have seen, is HTTP. So we recently also published a research that is dealing exactly with that. And but yeah, in the end, like to make it very, very quick, there is a pretty large difference when it comes to the data. And I'll just also show my screen to make it visual for people. So when it comes to performance, there are multiple things to consider always, like how large are the packets, how fast it is, and so on. And if we just look at the size of the data, just for sending 100 data points, messages, technologies like HTTP get incredibly large, like 550,000 bytes, while with MQTT, we still stay very low, like less than 10 times lower. And the more data one sends, the better the footprint gets with MQTT, because it uses this kind of standing connection. And this means there is always this open data channel that is very efficiently. And also when it comes to response times, there are also measurements, for example, if just comparing to HTTP, that for 1,000 messages, that the average response time gets very low. And this is our acknowledged data. This is really just not find and forget data. This is acknowledged data compared to our technologies. But for people interested in that, there are white papers out there. There are even reports out there which compare MQTT, CoAP, Modbus, OPC-UA. Especially OPC-UA is extremely verbose and extremely expensive on the wire, and so on. So there are the reports out there. Also happy to provide any links if people want to get their hands on that. Who really deal with that? There's research out there. Frankly, MQTT usually is one of the fastest ones when it comes to that. And MQTT Sparkplug, which provides semantics on top of MQTT, is also extremely low, especially compared to technologies like OPC-UA. But it's hard. I don't have a slide which compares all of the technologies here for this panel.
And one of the comparisons that came in from the audience as a question was, how does the data throughput from MQTT compared to RabbitMQ? I don't know if you have a perspective on that, Dominic.
Yeah. So to rephrase the question, RabbitMQ is a multi-purpose broker that is using the AMQP protocol. So the default, I think, is MQP 0.9.1, and it's using an old version of AMQP, but it's also compatible with newer versions like AMQP 1.0. It also has an adapter for MQTT. So technically, you could use RabbitMQ also for sending MQTT messages, but you only get a very small portion of the feature set. So I mean, I always recommend people to test the scenarios themselves. There are tools out there, like, for example, having to swarm is something where you can really benchmark the scenarios, because of course, everything here is biased. Every vendor will tell you something biased. But if you Google up any kind of benchmark against things like RabbitMQ to MQTT, you see that MQTT is usually orders of magnitude faster and uses less memory. And to give you one example, just one of the larger deployments we have with one customer, this is not an energy use case flow. They have more than 100 million topic subscriptions in the system, while usually RabbitMQ, you will not have more than 10,000 or so, and even that, or even 1,000. So you really can get orders of magnitude more because of the way how MQTT works. And also platforms like HiveMQ work. So there are platforms really optimized for that data throughput. We're talking about tens of thousands, hundreds of thousands, or even millions of messages, which means text basically per second being distributed with a single MQTT broker, which you usually cannot do with things like RabbitMQ. And there's also something about RabbitMQ. Just Google RabbitMQ and data consistency. The problem is RabbitMQ loses data, which for most of the use cases I know, this is not acceptable. So I would, if you're using RabbitMQ, there are, even if not using MQTT, there are solutions out there who are a bit better suited, depending on what you want to do. But for pure MQTT, if you don't need to use Rabbit, either go with an open source broker, something like Mosquito, or having a community edition, or go with a commercial vendor.
Great. And I know security is important and top of mind for a lot of folks these days, given the remote nature of assets. And, obviously some of them are localized, others are sending data to the cloud. How do you handle the reliability of data transfer over unreliable networks?
Very, very good question. So the good thing is that the MQTT protocol was designed for that. So this means that you have this kind of almost unstable connectivity. This is something MQTT was built for. And and how you can do that is usually there are three kinds of data that are being produced in most systems. The one is so-called fire and forget data. This is data that is there, you can send, but if it's lost, nobody cares so much. For example, this happens if you have a very high frequency production of data, like a temperature sensor that is producing data, whatever, every second. If you're missing a second, usually there's not a lot of harm. This is where we usually go with a fire and forget approach. A second approach is where you want at least once delivery. This means this is important data, and you want to make sure that the data is being transmitted and received and acknowledged at least once, but you could live with duplicates because for you are going the trade-off of reduced cost of data transmission cost, but you can live with duplicates. This is very often the case if you have, for example, a state change in one of your systems, like whatever this machine was powered on or so, then you really want to have this as fast as possible and then transmit the data. But you want to make sure that the data is received in the cloud or on the edge or wherever you want to send the data to. And then there is the case where you have so-called exactly once data. This is usually done for business transactions or for other things. You really want to make sure that the data is sent once and received once, and that the data handling layer is dealing with all of that, whatever reconnectivity and kind of duplications and so on. And MQTT has it built in. So you can actually use any MQTT software in the world and then just configure the kind of data quality you want to have. Do you want to have fire and forget quality, or do you want to get exactly once quality or at least once quality? And this is built in. So from an application developer perspective, I mean, it's really just setting a flag, basically, what kind of data quality you want to have. And also there's an interesting thing built into MQTT that many people are not aware of, which is called persistent sessions. This means if you have for example, you have a device and you really want to make sure that it receives commands and it loses cloud connectivity. What you want to do is, if it comes back online, it receives all the data, like commands that it should have received, as if it was on all the time. So an MQTT gives you the kind of, let's say, virtual connectivity that if a device goes offline and online again, the broker will make sure it sends all the data down to the device as if it was online all the time. And it really just gets a small service disruption in terms of it gets it later, because at the earliest time it has connectivity again. And MQTT has that built in. Like, you don't need to do anything. And this is also one of the reasons, because what I just said, this is an extremely hard problem to solve. And this is solved on the protocol layer and not on the application layer, like you usually do with some other more legacy kind of protocols. And this is being used by connected car scenarios. This is being used heavily also for remote asset management. This is also being used by factories, where you have factories that basically buffer data, and as soon as cloud connectivity is there, you send it online again.
Okay. Speaking about buffering data, we have a question from Brandon on, for fault altering use cases, does an overlay need to exist to configure parameters for the publish subscribe architecture?
I am not quite sure if I understand the question. But I think it's about high availability, basically, because when it comes to fault alerting, this means this is very critical usually. And I think it boils so if I interpret the question correctly, it's about, okay, how, or I just rephrase the question, and please, Brandon, if this is wrongly framed, I would like to for you to ask a follow-up question so I can clarify. But let's frame the question the way, how do you achieve high availability, like making sure if there's any problem anywhere in infrastructure that you really do not lose data? Because this is huge. Things fail all the time. So usually, and this is, by the way, the first thing usually architects point out with a typical publish subscribe architecture, which you have for many enterprise messaging systems. If the central data broker is going away because the infrastructure fails, because there is a networking problem, that the whole data center is down, there are many reasons why this could be the case, or just the application crashes. I mean, this is just software, right? As soon as the broker is not there anymore, all data communication is broken. So what you really want to make sure is, if you're using MQTT in a mission critical use case, you need to have an MQTT broker that has built-in high availability. And high availability in MQTT, the only sane way to get it done is with so-called clustering. There is usually, unfortunately, there are not too many things. Like, for example, there are open source software like Mosquito many people use, which do not support that in a way that you can have really full resiliency. There's commercial software out there like HiveMQ who supports it. This is basically how my company earns money with, because we make companies buy from us because we provide resiliency and high availability for mission critical use cases. This is the reason why our company exists, basically. And this is where high availability comes into play, because you can basically have many MQTT brokers in the same data center or in a different data center who are looking like one MQTT broker. And as soon as a part of the data center fails, as soon as, not only parts of the data center, but as soon as the servers crashes, if the application crashes, or if you have run on whatever cloud native infrastructure, Kubernetes, this is not a problem because you can just resume all the time, and devices can reconnect, and they can just resume as if nothing happened. And this is critical because the data infrastructure needs to be online all the time. And so, yes, MQTT provides the guarantees I just said, but only if the broker is there. So as soon as you're using MQTT in a critical environment, and usually most energy use cases I'm aware of are very critical, please make sure you have proper high availability and use clustering for that. And especially test it. Just test it and then basically kill a node and see what's happening. Because there are many claims out there, but I really ask you to verify that. So we have seen cases where something critical happened, and it's not HiveMQ software, but then the software did not provide the guarantees they needed in order to do that. And at least HiveMQ provides a solution that has 100% of the MQTT standard is supported in a highly available fashion. And so, yeah, please do that. When it comes to the second part of folder, this is the broker side. Please make sure that this is here. The second part is, how do you make available your clients, like, or your application consuming data? Like, what if one server dies here and you still want to consume the data? Here, you can just use the same mechanics you use for all your other applications, have redundant applications. MQTT supports basically two modes here. One mode is, for example, if I have an application consuming data from the field, I could have two applications, all of them consuming data at the same time, which might be great. Or you can even basically have a kind of data distribution model where the broker sends data to either one of those two. And so you basically can use both at the same time, because then you have an active mode. And nowadays, modern architectures use active modes. And we recommend this also to our customers. So MQTT has it built in. For the people interested, it's called shared subscriptions. It might be a bit over the top for this session, but also people are free to reach out to me, and I help them find the right sessions. Or just Google MQTT shared subscriptions, and there are some blog posts and videos available that explain the concept in detail. And also here, it's actually extremely simple. If you want to use that mode, it's actually in your MQTT library you're using for applications. It's just a switch, you switch it on, and then you get it. So from an application perspective side, it's simple. And last thing on that, MQTT, when I say it's simple on the application side, I really mean it's simple. And I challenge you that I'm pretty sure in less than a day, most people can even do this in less than a few hours, you will get a production application running on the client side. And the reason for that is MQTT was built for extreme simplicity on the client side and moves all the complexity to the broker side, to the server side. Because the thing is, if you have an asset out there, you cannot update that. It's so hard to update assets out there. So you really want to have a very simple software on the devices, and you want to have all the complexity in the data center where you have operations team where you can do updates and so on, because it's just such a hard problem to update things out in the field. And this is also true for most industries. And this is also why MQTT is so extremely popular, because it makes it simple on the application side, on the devices, on the assets, and moves the complexity to the data center, the cloud.
Great. We have a follow-up question, and a little bit more around the asset management component. With MQTT living as one part of the stack, we addressed some around the speed and capability earlier, but from more of a functional standpoint on asset management, like the ability to monitor by exception, ability to view current performance, health, etc. Are there various protocols you were talking about that can support that, or what would you recommend from a functional standpoint?
Yeah. So there's something, I mean, this really then depends a bit on the exact use case here. So, and this makes it a bit hard for this kind of online conversations. I would give a few things that might be interesting to consider. And otherwise, I invite people for a follow-up conversation where we can talk more about the exact details here. Something people really should be aware of is a communication protocol called Sparkplug, MQTT Sparkplug. And MQTT Sparkplug is something that was very recently developed, and actually by one of the inventors of MQTT, R. Nipper, who really pushed that initiative forward, because the great thing about MQTT is you can send any kind of data. The problem with MQTT is you can send any kind of data. And why is this the benefit and the problem at the same time? Because it makes it ultra flexible. This is why MQTT is used. So very likely, if you drive a car, the car you drive uses MQTT. I know that because most connected car platforms in the world are powered by HiveMQ. And this for most vendors in the world. And so the chances are very, very high that you're using MQTT already. But the thing is, if you're doing a connected car use case, or if you're doing remote asset management, you have completely different semantics, kind of data, and so on. And the problem is reinventing the wheel is something people shouldn't need to do. And this is why protocols on top of MQTT, like Sparkplug, IT4PT for public transport, Sphera for railways, and so on, were developed. And they are technically sitting on top of MQTT and providing semantics and data formats that make it interoperable. And Sparkplug is something that is really getting a lot of traction. And there's a Chevron, most people are aware of this company, I guess, also talks publicly how they modernized their whole stack with MQTT Sparkplug. And there are webinars out there who are recorded, who talk about this in detail. And I quickly shared my screen here, because what we see here, and this is more, now I'm zooming into a factory, but the principle apply also over the air. So please bear with me here. so what we see here, we have what I try to convey here is there's an OT-IT gap. And how people solved that in the past were like that. Point-to-point connectivity, just connecting stuff and see what's happening. Very unmaintainable, very unflexible. This is highly problematic. This is, by the way, what I sometimes call so-called spaghetti architecture. You get a nice bowl of spaghetti and nobody knows what is connected to whom, what kind of policies are in place, and so on. This is usually what one does not want to have, neither in a factory nor in remote, if you're monitoring something remote. And now new architectures like that come into play, where we have different kind of systems. And again, this is now manufacturing centric, so apology for that. But here we have so-called manufacturing execution systems. There are historical analytics things and applications. And here we have gateways, we have OPC UA, Modbus, we have digital in-out, we have analog in-out, and so on. And usually we have this kind of gateways. And how people solve that here is to bridge the gap. This is MQTT. We talked about it already. The problem is, and I said that already, when it comes to something standardized, there needs to be a specification on top of MQTT that says how is data formatted, how are the endpoints, how is the behavior of the endpoints, how are the topic structures, and so on. And this is why the Sparkplug working group was basically formed. And it goes out there and it wants to provide a simple and an open specification that will enable plug-and-play interoperability between IIoT devices and applications. And it does that by defining a so-called topic namespace, data models, state management, and so on. And it uses things like auto-discovery, because what you really want is you want to plug in something and you want to have auto-discovery. The same kind of thing that OPC UA vendors are claiming now for, I think, since 2008. I mean, I think there are many projects where this worked, but the reality is a bit more, let's say, complicated. Sparkplug uses a different model because Sparkplug uses this kind of MQTT brokered model, which means all the devices are known by the broker and are managed by the broker and all of the assets, basically. This means the broker can, with Sparkplug, understand things and help with auto-discovery because it can distribute all the data. And you have this kind of report by exception thing where you can distribute the data as needed. And unfortunately, we run out a bit of time here to talk about Sparkplug in detail. I recorded a quick series on YouTube also where I talk about the Sparkplug concepts in a few minutes. So for people who are interested, just Google Sparkplug Essentials and you will find a white paper, blog posts, and a video series if you want to learn more about it, because Sparkplug is highly relevant for the energy industry. And so I cannot talk about this publicly, unfortunately, here in this format, but there are so many great use cases out there using Sparkplug who are literally transforming their whole business we're talking about months here and not years, by introducing this technology. And it's not a either or. This means you can use your existing Modbus technologies, you can use your OPC UA technologies, and you can add Sparkplug into the mix and build upon it without replacing things. I mean, I have never seen a greenfield project in my life, unfortunately. There was always prior art, there was always something before. And so if you're lucky enough to have a greenfield project, great, this is really great. I really envy you. I've not seen so many of them yet. This means one needs to deal with what is there. And now modernizing should really work in a way where you integrate what you have and then enable for the new use cases coming ahead. And this is something Sparkplug provides really out of the box. If you don't believe me, try it out for yourself.
So back to your architecture model there, Dominic, and going from spaghetti to a more streamlined component, how's the data governance and segmented security effectively managed? Obviously, assets are imperative to make sure that security is there. What do you see as the benefits and immediate value from a security lens?
Yeah, a lot of them. So I just looking at, so I have actually, I do presentations on security on that topic, like which for a whole hour, because it's a large topic and there are so many benefits also. But to make it short, there are multiple things to consider. One thing is, and this is a tech vector for remote assets. If you're exposing your assets with a public address remotely, even if you secure it, people can denial of service your things, your assets. And this is a huge problem. There are cases out there where, although attackers could not get into or send data, they could denial of service things by just basically pushing in so many false requests that basically the compute did not could not handle that, or the memory and so on. So this is why don't put things publicly on the internet if you cannot defend that things, especially if they're on remote sites and so on. Don't do that. This is why MQTT uses a different approach. The devices connect to the cloud, and you don't need to open a port, technically speaking, a port to the outside. This means it's not accessible from the outside. And this is called, this uses not network address translation for people who are interested in that. But to make it short, by using MQTT, you don't have an attack vector for denial of service attacks for your devices. This is number one. So the second part is on the broker. Your devices connect to the broker. You really, really, really want to make sure that only devices who are allowed to receive data and commands are able to do that. And you do that by, as simple as it sounds, by policies. With MQTT, you have fine-grained policies like who is allowed to send data, to receive data, and even for our customers are using it even for defining what kind of quality of service levels can be used, like is this device allowed to use exactly once messaging or only file and forget messaging, and so on. And this is something that's done centrally managed on the broker. And with that central management, you just need to change it on one thing. You don't need to go out to all your devices and change something. You just use it mentioned in one way. And for the people who are really interested how to do that, we have a thing called the Enterprise Security Extension that can connect to your databases, to your asset databases, to microservices, and even to things like OAuth servers and so on, like more on the enterprise IT side of things. This is something we believe that should work out of the box. Security is something one needs to consider from the beginning. And in order to do that, it needs to be extremely simple. And fortunately, with MQTT, you can do that. One last remark on that, use encrypted communication always. Always use TLS. Then you have an encrypted channel. And then just with these recommendations, you're good to go. Otherwise, Google MQTT security fundamentals. I also have a series on that online where I wrote about this in a bit more elaboration for people who are really into security. Okay.
Thank you so much, Dominic. This has been great. And as technology continues to evolve and advance, it's great to see where the IT/OT continues to converge and where we're headed with IIoT and MQTT to really drive the asset management and how we monitor and maintain our advancement in the energy industry. So I really appreciate your time, and thank you everyone for joining us today, and hope you join continued sessions as we go out throughout the rest of the day.
Okay, thank you everybody.